This is where we left off. We did talk about the derivatives of the inverse trig functions, and then we started talking about the antiderivatives or the integrals of the inverse trig functions. And basically, it's just knowing how to use your formulas page. If you know how to use your formulas page and you know how to do the derivatives and the antiderivatives, you should be fine. But again, a lot of you are struggling with the derivatives and the antiderivatives, so you need to kind of catch up on that just a little bit. All right, so we went through this problem. And remember, what we're trying to do is we're trying to make our integral look like one that's on our formulas page. Well, this one, when I look at this one, I can see that I have a squared plus u squared. So if u squared is equal to e to the 2x, then u is equal to e to the x. And I showed you why. Just remember on these problems, when you find u, make sure you do du because it is u substitution. So you should be able to check things off. Once you have your integral the way you need it, in other words, the way it looks just like one of the ones on your formulas page, all you have to do is substitute in for your formula, and of course using the u and the a. So if we go here, if we have the integral of cosine x is equal to 9 minus sine squared x, well, what do you think? Let's go with the easy one. What do you think a squared is? A squared is going to be 9, so a is going to be 3. What do you think u squared is? Sine squared x, so u is going to be what? Sine x. So what is du going to be? What's the derivative of sine x? Cosine x dx. So look, we can check them off. So now what you're going to have is the integral of 1 over the square root of a squared minus u squared du. Do you see that on your formulas page? Do you see 1 over the square root of a squared minus u squared du? Okay, so all you got to do from there is copy it straight off your formulas page. So what you're going to have is 1 over a tangent inverse of u over a plus c. And of course we'll plug in, what did we say a was? 3. And then you have tangent inverse of u, which we said was sine x, over a, which we said was 3, plus c. And that's all you have to do. As long as you don't need any compensations or anything like that, that should be all that you have to do. But, can I not copy it off? Yeah, it is sine. Thank you. Can't even copy it off the page. Well, it's even easier than that, isn't it? Okay, let's try this again. Square root, a squared minus u squared. Okay, so it's going to be sine inverse of u over a plus c. There we go. Is that better? So you have sine inverse of sine x over 3 plus c, of course. And remember, a lot of people think, well, I can cancel sine inverse and sine out. No, you can't, because sine x over 3 is the argument of your sine inverse. That's not multiplication, okay? So you can't cancel those out at all. So yes, that's all you can do. Questions? Anything else? Okay. Let's see if we can make this one look like something on our page. Do you see something that looks like this? First, second, or third? Third. Good. So u squared is going to be what? X squared. So u is going to be x, and du is going to be what? Dx. So we're good. And a squared is going to be 9, and so a is going to be 3. So let's see if we can figure out the formula. So we're going to have 1 over x is u, and then the square root of u squared minus a squared du. And that is the third one, so that is your secant. So you're going to have 1 over a secant inverse of u over a plus c. And let's plug in. So we're going to have 1 over 3 secant inverse of u, which is x, over a, which is 3, plus c. And again, that's all you can do. So I guess the hardest part is trying to get your problem to look like one of your formulas. If you can get your problem to look like one of your formulas, you're good to go. Some of them you'll have to play around with. Some of them are very straightforward. Try this one. See what you can do on this one. Which formula do you want to be your goal? First, second, or third? Yeah, it's going to be the second one. It is going to be the second formula. So what is u squared? 4x squared. So what is u? 2x. So what is du? 2 dx. U is always going to be your variable term. Since the plus sign, it can be switched. If it's the minus sign, it cannot. Because remember, addition is commutative, but subtraction is not. So with the addition, it can be switched. Okay, what's wrong with the du? So I'm going to have to use a compensation on this one. So you're going to have 1/2 du is equal to dx. Now I can check it off. A squared is going to be 25, so A is going to be 5. Yeah, please remember that your u always goes with your variable term. U is always your variable term, and A is always your constant term. We said that last week, but I know it's been a long time ago. So. All right, so we are going to have 1/2 times the integral of 1 over u squared plus a squared du. So you're going to have 1/2 times, we said that was the one in the middle. So we're going to have 1 over a, tangent inverse, and if you want to skip this step and go ahead and plug it in, that's fine. Plus c, so you're going to have 1/2 times 1 over a, 1 over 5, tangent inverse of u, which is 2x, over a, which is 5, plus c. So what are you going to multiply that 1/2 by? 1/5 only, and that's it. So you're going to have 1/10 tangent inverse of 2x over 5. Don't multiply that 1/2 times the 2x over 5. That's your argument. That is the argument. You've got to be able to pick out the difference between the argument and a coefficient. And that's it. What do you think? Any questions? Okay. So let's talk about hyperbolics. Again, we're going to do derivatives and antiderivatives of the hyperbolics. Hyperbolics, it's a different language. Some of the trick stuff goes with the hyperbolics and some of it doesn't. Some of the identities you can use and some of them you cannot. And the reason being is a lot of people don't understand this, but hyperbolics, they're not trig-based. Instead, they are e-function based. They're natural log based. Okay? So, for example, here you have, now when you say these or when you hear me say these, make sure you understand what I'm talking about. The sine h, the hyperbolic sine h of x, I'll say sinh. Okay, so that'll be sinh, and the next one will be cosh, and then you have tanh. then you have cotangent, and then you have sech, and then you have cosech. So it's, well, no, it's calculus. So just understand the terminology. Again, hyperbolic sine will be sinh, hyperbolic cosine will be cosh, hyperbolic tangent will be tang, hyperbolic cotangent will be cotang, hyperbolic secant will be sech, and hyperbolic cosecant will be cosech. Okay, so when you see a hyperbolic sine of x, you can see that it is the function of e. So you have e to the x minus e to the negative of x over 2. That's what the hyperbolic sine is equal to. So it's not trig-based. It is not trig-based. They are e functions. Now, on your calculator, I need you to find the hyperbolic button. For those of you who have the loved calculator, your hyperbolic button is the second and the half. For those of you who have a different calculator, so what I want you to do is I want you to do second half. I want you to hit your hyperbolic and then hit sine. Do you see the sine h? You should see a sine h on your calculator. From there, type in the natural log of 4 and hit equals. You should be coming up with 1.875. Is that what you got? Now, for those of you who don't have the Texas Instrument, if you have a Casio or something like that, make sure you can come up with 1.875. A hyperbolic, yes. Yeah, because that's your argument.
I mean, it's just understood that you have to put it's hard to do it. You don't know the type.
No.
Okay.
Well, explain to me what
You know how you said do natural log? Like that's given, it's not only written.
it is written.
Oh,
That's what she was.
yeah, right.
Okay, so for the next one, you have cosh of 4. Do second pi, or hit your hyperbolic button, and then hit cosine, and it should come up with cosh, and then just hit 4, because that's your argument, and hit equals. Again, you should be coming up with 27.308. Okay. For the next one, again, get your hyperbolic in there, and hit tangent, and you should see tang. And then just hit 3. And you should be coming up with 0.995. Now, the inverse trig functions. For example, if you have cotangent of negative 10. On my calculator, on the TI calculators, what you're going to do is you're going to hit hyperbolic tangent, negative 10, and then you have an inverse button, which is the x to the negative 1, I think. So this is what I want you to do, okay? Follow along. Get your hyper button in there. And then hit tangent, because this is cotangent. But when you tangent, and then do negative 10, and then close your parentheses if it opens. And then hit the x to the negative 1, your inverse button. And hit equals, and you should come up with negative 1.000. And they round it. Did you come up with that? Hit second pi and get your height button, and then hit tangent, and so you should see tang. And then hit negative 10, and close your parentheses. And hit your x to the negative 1, which is your inverse, which will give you the cotangent, and hit equals. So for sech, what you're going to do is you're going to hit your hyperbolic, cosine, and then it should say such. And then hit -2. Close any parentheses that opened. Hit your inverse button, which is x to the -1. And hit equals, and you should be coming up with 0.266. Yes? Okay, so for the last one, again, get your hyperbolic up there. And cosecant is the inverse of sine. So you're going to hit sine. Hit 1. Close any parentheses that open. Hit your inverse button or your x to the -1 button. And hit equals. And again, you should come up with 0.851. Okay, so are we clear on how to get hyperbolics on our calculator? If not, again, we can talk about it in the break, and I can help you do that on the break. So why do we use hyperbolics in the real world? Well, power lines. Power lines have a little bit of a sag in them, right? And it's due to weight, tension, force, whatever. Well, electrical engineers use these hyperbolics to figure out how much sag can be in a line to meet regulations, for example. So they are useful in the real world. Most of the electrical engineers that I know, they have formulas in their computers that do it for them. But again, you have to know, is it possible? Because if you have a power line that has a sag of 27 feet, that's not good. Wouldn't think. All right. So first thing we're going to do is we're going to learn how to do the derivatives of these. You do have formulas for them. It's on the bottom section of your Chapter 8 formulas. So, again, remember when you're doing derivatives, for example, for the very first one, it says d sub x. That's the derivative of sinh u. The derivative of sinh u is cos u times du times the derivative of u. Don't forget to do that. Okay? Don't forget to do that. The only time you don't have to worry about the du part, the derivative of your u, is when u is x. Because what's the derivative of x? It's just 1. But if you have a u that's anything aside from x, you have to throw that du in there. You have to. Okay? So let's look at this one. If it says, if your f of x, if your function is sinh x squared plus 1. Now here is your u. So do you think we're going to use the du part? Do you think we're going to use the derivative of u? Well, yeah. Because I just told you, if u is anything aside from x, you need to use du. You have to use du. So if u is equal to x squared plus 1, what is the derivative of u? Okay. So let's work on f prime of x. Go to your formulas page, and if you have sinh u, the derivative of sinh u is cos u, so you're going to use cos u times the derivative of u, which we said was 2x. So to write that in algebraic or trigonometric terms, you have 2x, because that is a coefficient. So you have 2x cos of x squared plus 1. That's the proper way to write it. Okay, so you try this one. Now remember all the ways that you can do the derivative. You have just the straight up derivative, you have your chain rule, you have your product rule, you have your quotient rule. All of those are going to come into play. All of those are going to come into play. This one, for example, what do you see? It's cubed, so what rule is that going to be? That's going to be your chain rule. That's going to be your chain rule. Because remember, we can rewrite this. Now, do you know how to do the chain rule on that? Chain rule says what? Take the 3 and do what with it? Bring it down front. Do I mess with cos x right now? No, I'm not messing with cosec right now. What do I do with the exponent of 3? Lessen it by 1. That's just straight up derivative, right? Now, what do I have to do? Times the derivative of what's inside. What's the derivative of cos u? It's going to be sine, actually it's going to be sinh u. It's going to be sinh u times the derivative of u. But what is u this time? U is x, so we don't really have to worry about it. I mean, I'll write it in there just so you know. But the derivative of cos u is going to be sine u du. But the fact that u is x this time doesn't really matter. Okay, clean it up a little bit. There's not really that much you can do. Just, I guess, descending order would be nice. Alright, so you have 3 sinh x cos squared x. Oh, that's not even in descending order. That's okay. Either it's multiplication, so it's commutative. Alright. This one, arctan, what does that mean? What's another way of writing arctan? So you have tangent inverse of tanh x. And we need to find the derivative of that. Now, what is tanh x? Is it a coefficient? Is this a product? Is it an argument? It's the argument. This is not the product rule. Tanh x is the argument of the tangent inverse. Well, in order to do f prime of x, I need to know how to find the derivative of tangent inverse of u. How do you find the derivative of tangent inverse u? We did this last week. The derivative of tangent inverse u is 1 over 1 plus u squared du. So, the derivative of tangent inverse of u is going to be 1 over 1 plus u squared, which is going to be tangent squared x, or tanh squared x, times the derivative of u. The derivative of tangent inverse u is 1 over 1 plus u squared, but u in this case is tanh x. So if u is tanh x, what is du? Got to go to the other ones. The du of that is going to be what? The derivative of tanh u is sec squared u. U in this case is x, so we don't need to worry about the du. I mean, I can write it in there if you want me to, but the derivative of x is just 1. So, go back to your problem. The derivative of tangent inverse is 1 over 1 plus u squared. And in this case, u is tanh x. Times the derivative of u. Well, the derivative of tanh x is sec squared x. And then, like I said, the du is not going to matter. Now, what I want you to do is this. I want you to look on page 443. And I want you to look at the identities on page 443. There's a little square that has the properties of the identities. So on page 443, can I replace 1 plus tanh squared x with sec squared x, which is what some of you are wanting to do? What does the identity say? It's 1 minus understand these identities. This is your answer. You can't simplify it. There's nothing that you can do. Just leave it be. That's what it's going to be. So don't try to make something into what it's not. Be very careful with that. Okay, so let's look at this one. What do you see? What is your function? I ask this question all the time in Cal 1. What do you see? Quotient. This is a quotient. Therefore, you're going to have to use the quotient rule. Do you remember the quotient rule correctly? Do you remember the quotient rule? What is it? Low D high. That's your quotient rule. Low D high minus high D low over low low. Okay, so let's find f prime of x. So you're going to have low, which is cotangent x, times the derivative of high. What is the derivative of cotangent x? What is the derivative of cotangent x? On your formulas page. Negative cosec. Hyperbolic cosecant. Is that better? I don't care how you say it. Just write it down correctly, especially. U is x this time, right? So we don't have to worry about that. So the derivative of hyperbolic cotangent x is negative hyperbolic cosecant squared x. So you have low times the derivative of high minus the high, which is hyperbolic cotangent, times the derivative of low. What's the derivative of cotangent? That's off your Cal 1 sheet or the inside front cover of your book, either way. The derivative of cotangent of x is negative cosecant squared x dx, which is going to be 1. So you have low D high minus high D low all over low low, which is going to be cotangent squared x. Now this one, I mean, there's a little bit of cleanup, but not, I mean, nothing major. Basically, it's just your signs. And that's all you can do with that one. Alright, so we have the straight up derivative, we have the chain rule, we have the quotient rule. So what's left? Product rule. Do you see the product in this one? Do you see the product in this one? This is x times hyperbolic cosecant e to the 4x. So that is a product. Okay? So do you remember the product rule? First times derivative of the second plus the second times derivative of the first. This is multiplication and addition, so it's commutative throughout, so it doesn't really matter which one goes where. Alright, so f prime of x. Are you kidding me? Alright, f prime of x. F prime of x is going to be first times the derivative of the second. Now, watch this. This is going to get crazy. U is equal to e to the 4x. Du, what's the derivative of e to the u?
E to the u,
e to the u du. So it's going to be e to the 4x times the derivative of 4x, which is 4. So du is going to be 4e to the 4x. Okay. So you have first times the derivative of the second. The derivative of hyperbolic cosecant e to the 4x. What do you think? It's on your formulas page. All you got to do is write it down. So the derivative of hyperbolic cosecant e to the 4x is going to be negative hyperbolic cosecant u times hyperbolic cotangent u times the derivative of u, which we said was 4e to the 4x. Okay, so you got first times the derivative of second plus the second and the derivative of x is just 1. Alright, so clean up. Now, in the first grouping, can you tell me what the coefficient's going to be? What can I multiply together? So you're going to have 4x e to the 4x. Those are the only things that I can multiply together. Those are the coefficients. And you can throw the negative. So now you're going to have negative 4x e to the 4x, and it's going to be cosecant hyperbolic e to the 4x, cotangent hyperbolic e to the 4x, plus hyperbolic cosecant e to the 4x. And that's all you can do with that.
Why don't you divide, why don't you put 4 when you do d is 4e.
4x? Because this right here. Because the derivative of e to the u, in this case, e to the u, well, u is equal to 4x. Okay? So if f of x is e to the u, then f prime of x is e to the u du. That's on your Cal 1 sheet. If you got that. Number 7 on the Cal 1 sheet. So when you do the derivative, if u is equal to e to the 4x, this time u is 4x. So it's like you just keep on linking it in the chain. So if you have e to the 4x, the derivative of e to the 4x is e to the 4x times the derivative of 4x, which is 4. So it turns into 4 times e to the 4. It's crazy, isn't it? Anything else? Okay, let's try one last one. Here we have the natural log. Now listen to me, okay? If your function is the natural log of u, from Cal 1, what is the derivative of natural log of u? 1 over u. Very good. Du, of course. Okay? So, if your function is the natural log of the hyperbolic tangent x, then your derivative, your f prime of x, is going to be 1 over u, don't mess with it yet, times the derivative of u. This is u, okay? So if u is equal to hyperbolic tangent x, then what is du? Go to your formulas page. The derivative of the hyperbolic tangent x is secant, hyperbolic secant squared x, and then the derivative of x is just 1. So So when you do this, you're going to have hyperbolic secant squared x over hyperbolic tangent x. Now, I mean, really and truly, there's nothing that you can do with this. If you wanted to replace that hyperbolic secant squared x with 1 plus tangent, but it's not going to get you anywhere, so may as well just leave it as is. Okay, so we've done derivatives of inverses, we've done antiderivatives of inverses, and we've done derivatives of hyperbolics. Questions so far? It's straight off the formula page. Straight off the formula page. Okay, so now let's do the antiderivatives of the hyperbolics. Again, that's on the back side of your formula page if you ran off front and back, or it's on the second page, however you want to look at it. So the antiderivatives are the integrals of the hyperbolic trig functions. Again, if you have the hyperbolic, or if you have the antiderivative of hyperbolic sine u du is going to be hyperbolic cosine u plus c. You have to pay attention to that u. You have to pay attention to that u. A lot of these may have u substitution, so be aware. Don't forget to do du. Once you pick out u, don't forget du. Don't forget u substitution on these. It's very, very, very easy to do. Okay, so alright, so if we have the integral of hyperbolic sine 3x dx. So compare this, again, compare this to your sheet, your cheat sheet. What you have on your cheat sheet is the antiderivative of sine, or hyperbolic sine u du. Well, like I just said, what is u? So what is du? Well, this is just like u substitution. I don't have a 3 dx anywhere, do I? This is u, and I need du just to be dx. So I'm going to have to use a compensation. So I need 1/3 of du is equal to dx. All right, so 1/3 the integral of hyperbolic sine u du. And again, if you want to just go ahead and write it straight in, you can. So you're going to have 1/3. The integral, or the antiderivative of the hyperbolic sine, is going to be hyperbolic cosine u, which we said was 3x, plus c. When would we not end an integral with plus c? If you have boundaries. Don't forget that. That will come up sometime or another. Okay? So let's go back to Cal 1. Can you anti-differentiate? Can you find the antiderivative of a quotient? No. Well, in Cal 1, we would just say, oh, well, this is going to be a hyperbolic secant inverse of 7x dx. Not so easy. Okay. What you're going to have to do, well, first of all, you know, I haven't even done that, but anyway. What you're going to have to do is think of trig, basically. So instead of doing 1 over hyperbolic secant of 7x dx, how can I change that to where I can do the antiderivative? And again, think about it, okay? If you want to do the little trick that we did in Cal 1, okay, so that's going to be the antiderivative of hyperbolic secant -1 7x. Can you find anywhere on your sheet where you're finding the integral, the antiderivative of a hyperbolic secant? Look on here and tell me where you see an antiderivative, an integral symbol of the inverse of hyperbolic secant, or hyperbolic secant -1. Do you see anywhere on this sheet where I can take the antiderivative of the inverse of secant, hyperbolic secant? No. So that right there tells you you can't use that trick. Do you understand what I'm talking about? In Cal 1, if we had to do the integral of 1 over x squared, we would just do the integral of and fix our problem. Can't do that here because you don't know how to find the antiderivative of a hyperbolic inverse. So that won't work. So instead we have to go back to trig. So what is 1 over secant equal to? Cosine. So 1 over sec, or hyperbolic secant, is equal to cosec. Now, look at your formulas page. Can you find the antiderivative of hyperbolic cosine 7x? Yes. What is u going to be? What is du going to be? For those you can. Okay, so here is u, and I need du just to be dx. So am I going to have to use compensation? Yes. So I need 1/7 of du to be dx. So we're going to have 1/7 the integral of hyperbolic cosine u du. Go to your formulas page, find that, and so you're going to have 1/7 hyperbolic sine u, which is 7x plus c. Again, straight off the formulas page. If you can make your problem look like any of the integrals or derivatives on your formulas page, all you got to do is copy it straight in. But on these, please don't forget the u's and the u substitutions. Okay, let's look at this one. There's a problem here. What is it? It's a product. We don't know how to find the derivative of, or the antiderivative of a product. You cannot integrate a product. So let's work on this. Tell me what you think u would be. So what would du be? Again, we need to work on derivatives and antiderivatives. It would be 4x dx. Well, I see a x and a dx, so I can fix this, can't I? And now I have it. Watch this. This turns into 1/4 times the integral of hyperbolic sine of u du. Do you have that on your formulas page? On your formulas page, it says that the integral of hyperbolic sine u is hyperbolic cosine u, which I'm going to go ahead and put back in. Let's see. Try it. Before you start panicking, look at your formulas on your formula page. Do you see a hyperbolic secant squared? Yeah, so there's no need for panic, right? If you see a hyperbolic secant squared, then all you got to do is your u compensation. What is u? So what is du? So what would your compensation be? And you're good to go. So you have 1/5, the antiderivative, and again, if you want to go ahead and go straight to your substitution, that's fine. So, the antiderivative of hyperbolic secant squared u is tangent hyperbolic tangent u, which was 5x. Let's see. How'd you do? You got it? Okay. Let's do one that looks like this. Now again, before you start panicking, I want you to compare this to your formulas page. Do you see one? Do you see one that says hyperbolic secant u, tangent, hyperbolic tangent u? So there's no need for panic. You have the antiderivative for this right here. All you need is a u substitution. U is 3x. Therefore, du is going to be 3 dx, which is not what I need, so it's going to be 1/3 du equals dx. So now I'm good to go. So I'm going to have 1/3 times the integral of sec u tanh u du. So the antiderivative of that is what? Negative. I'm going to go ahead and throw the negative out front. Is that okay? So you have negative 1/3 sec 3x plus c. So if it looks crazy, just take a step back, breathe, and look at your formulas page. Don't panic on me, okay? Try it. Do you have on your formulas page an antiderivative for tanh u? So now you can start panicking, right? No. What is tangent? Sine over cosine. Well, how in the world is that going to help me? So that's going to be hyperbolic sine x over hyperbolic cosine x dx. That doesn't help because you can't take the antiderivative of a quotient unless you do what? If you can't find a straight substitution and you can't integrate a quotient, what's your only other alternative? What's the only way that you know how to get out of a mess? By using u substitution. Now, you can go one of two ways here, but we need to think logically, okay? If I let u be hyperbolic sine, what is du? It's on the other page, the other side. What is du? Hyperbolic cosine dx. Is that what we have? No, because what we have is hyperbolic sine times 1 over hyperbolic cosine. That's not what we have. So you can't use sine. Well, let's try to use cosine. If u is hyperbolic cosine, what is du? Hyperbolic sine? Dx? Is that what we have? Yes. That's exactly what we have. So this is going to turn into the integral of what? 1 over u du. Cal one time. What is the integral of 1 over u du? It's going to be the natural log of u plus c. Well, what did we say u was? Hyperbolic cosine. Y'all are so funny. Y'all don't want to say that. That's all it is. I mean, you can say kosher. You can say hyperbolic. I don't care. If you don't want to speak calculus, that's fine. Okay, so we've done derivatives and antiderivatives. We've done derivatives and antiderivatives of hyperbolics and hyperbolic inverses, and we've done just the straight up inverses, the derivatives of the inverses and the antiderivatives of the inverses. So we've got one more thing to do. We're going to do the derivatives of the hyperbolic inverses and the antiderivatives of the hyperbolic inverses. They're not bad. They're just like what we've been doing. Okay, it's exactly like what we've been doing. Okay, so hyperbolic inverse. Again, the first thing we're going to do is the derivative, and these derivatives are on your cheat sheet. Obviously, we only have 2 more of these to go. So this is the derivative of the inverse hyperbolic trig functions. So when you do the derivatives, again, like we were talking about a while ago, as long as it's addition, it doesn't really matter. But look at the last 3. The last 3 are subtraction, so make sure you get those right, because those do matter. Subtraction is not commutative, so make sure you get those right. Once you know what u is, you're good to go. Alright, so if my function is the inverse hyperbolic sine of e to the x, okay, find that on your sheet, find that on your cheat sheet. You have that if your function is hyperbolic sine inverse e to the x. So what is u? What is du? It's still e to the x, right? The derivative of e to the u is e to the u du, but u is x, so the derivative of x is 1. I think I've said that like 10 times now. Alright, so follow your sheet. So, f prime of x, the derivative, is going to be 1 over the square root of u squared. Can you tell me what e to the x squared is? Yeah. Power to a power, we multiply. So it's going to be e to the 2x plus 1 times the derivative of u. What is the derivative of e to the u? Or e to the x? E to the x. Don't forget to do that. Don't forget to do that. If you miss something on this test, it'll be that e to the u, and it'll be the du part. That'll be what you miss on the test. It'll be the du's and the derivatives, and it'll be the compensations and the antiderivatives. So be careful of that. Alright, so cleaning that up, there's really not much you can do. So you have e to the 2x plus 1. Alright. What rule are you going to use on this one? y. Rewrite this. What am I going to do? Now, do you see your chain rule? That's your chain rule. So the derivative, we're going to move the 1/2 out front. Leave what's inside alone for now. Lessen the 1/2 by 1, so that's going to take me to negative 1/2. Now, let's do the derivative of hyperbolic inverse cosine, all of it together, of x. What's it going to be? The derivative of the inverse hyperbolic cosine. Do you see it? 1 over the square root. What is u? What is du? I'm sorry, I don't need du. What is u squared? Sorry. There you go. Alright, so we're going to have x. So you're going to have 1 over the square root of u squared, which is going to be x squared minus 1. And then again, the derivative of u is what? So we don't have to worry about it, right? Okay, cleaning this up is going to be fun. What goes on top? 1, nothing but. On bottom, we have the 2. We have the square root, or if you want to leave it to the 1/2, you can. There needs to be a negative 1 in there. And why did I put that in here? Now on the bottom, I mean, if you want to distribute those radicals out, you can. Totally not necessary. But if you want to write it as 2 times the square root of 2 hyperbolic inverse cosine x minus hyperbolic inverse cosine x, you can. Not necessary though, at all. Does everybody see what I did? Try it. What do you see here? Is this the product rule? No? Sine 3x is the argument of your inverse hyperbolic tangent. Sine 3x is your argument. That's your u. That is your u. Okay, so to find the derivative of the inverse hyperbolic tangent, go straight off your formulas page. Again, u is sine 3x, just so we don't have any confusion here. So on the formulas page, what do I need? Inverse hyperbolic tangent of u is going to be 1 over 1 minus u squared. Well, I have u, so what would u squared be? Sine squared 3x. So that's what you're going to put in here. And then remember, times the derivative of u. What is the derivative of sine 3x? It's going to be cosine. Why are we not writing? Cosine, really? Times what? Why do I need that 3? The derivative of sine u is cosine u du. U is not x, u is 3x. So du is going to be 3. So you need that 3 in there. Don't forget that. Alright, so this is going to be 3 cosine 3x. What do you think? You want to be done with this one? You can. You want to stop there? Because I wouldn't give you full credit. Can you tell me why? Yeah, you have your Pythagorean. 1 minus sine squared 3x is the same as what? Now what? Yeah. Now you can cancel out a cosine 3x. Now you can stop. Actually, if you wanted to put 3 secant 3x, you could do that too. But either one of those is fine with me. So, if you got 3 cosine 3x over 1 minus sine squared 3x, I would give you most credit. But I would appreciate it if you went on farther. That would be awesome. Alright, so this one. What do you see here? On your formulas page, do you have a derivative for the hyperbolic secant inverse u? Do you see a derivative for that on your cheat sheet? You should. What is u? Joy, joy. Okay, so let's fill in. F prime of x, the derivative for the inverse hyperbolic secant u, is -1 over u, which is this, square root of 1 minus x, times the square root, I guess we could write it. I don't know that it's going to make any difference. We'll see. Square root of 1 minus u squared. Now, u squared we don't have. What is u squared going to be? What happens when you square a square root? They cancel out, and so you just get 1 minus x. Okay, so that's the derivative so far. Now what? Du. So if u is the square root of 1 minus x, what is du? What do you have to do here? Chain rule. Very good. Now the derivative of what's inside is going to be -1 this time, okay? The derivative of 1, of course, is 0, but the derivative of negative x is -1. So that is going to come into play. Okay, so let's multiply that times -1/2 of 1 minus x to the -1/2. Now this is going to clean up a lot. Well, I say a lot. Pretty good bit. Let's see what we can do. What do you think? What's going to go on top? Just 1. Negative times negative goes to positive. Now, on bottom we have a 2. We have a square root of 1 minus x. We have another square root of 1 minus x. And then we have a square root of a plus x. Because 1 minus x is when 1 minus 1 plus x. Those are going to cancel out. Not cancel. No. Yep. Square root of 1 minus x times square root of 1 minus x is the square root of 1 minus x quantity squared. What happens when you square a square root? Cancels out. So what you're going to have now is 1 over 2 square roots of x times 1 minus x. And that's all you can do. Alright, go on break. Okay. So the last thing we're going to do is we're going to talk about the antiderivatives for the inverse hyperbolics. So, just like the previous antiderivatives, what you're going to try to do is you're going to try to get your problem to look like one of these. And again, with these, order does matter. Now, having said that, with this one, if I want to change it up or if I need to change it up, I can take the negative out and do 1 over u squared minus a squared. But the order does matter. If you change that denominator up for that one right there for your hyperbolic tangent, then you have to take the negative out and then do 1 over u squared minus a squared. So that is possible. But the other two cannot be changed up. Okay, so again, what you're going to do is you're going to look at your problem and you're going to see if you can make your problem look like one of these formulas on your formulas page. So let's look at this one. What do you think u squared would be? Or let's just say, what do you think u would be? What? What would u be? Either one, u squared. What would u squared be? 16x squared, so u is going to be what? 4x. And so du is going to be what? Okay, so what would a squared be? And what would a be? 3. So what we're looking at is the integral of 1 over the square root of u squared minus a squared du. Do you see that on your formulas page? Which one is it? First, second, third, or fourth? It's going to be the second one. All right, so the antiderivative is going to be hyperbolic cosine inverse of u, which we said was 4x, over a, which we said was 3. But there's a problem. What's the problem? Well, do we have a straight substitution for u squared? Do you have a straight substitution for u squared? Do you know what u squared is? What is u squared? 16x squared. It's not a trick question. What is a squared? 9. What is du? That's a problem. Because I don't have a 4 dx. I just have a dx. That's the problem. Do you see that? This can be substituted for this. That's good. 9 can be substituted for a squared. That's good. However, dx cannot be substituted for du, or vice versa, because that's not what I have. There has to be a compensation. And that's what I was saying a while ago. If you mess up on this test, it's going to be either taking the derivative of u or doing your u substitution, your compensations. Do you see what I just did? One over the square root. What is 16x squared? Look over to the right. What is 16x squared? What is the straight substitution for it? U squared. What is 9a squared? What is dx? Now we have it. Dx is 1/4 du. The 1/4 you know goes out front, and now I can substitute dx for du. Or du for dx. Please don't forget the compensations. Now we can do what we were going to do a while ago. So now we have 1/4 times, and go back to the second one on your formulas page, which is going to be inverse hyperbolic cosine u. What is u? Over a. Please don't forget your compensations. All right, let's see if we can do this one. Does it look something like one of the ones on your paper? We're going to try to get it to look like which one? The first one. We're going to try to get it to look like the first one, okay? So what do you think a squared would be? 1. What do you think u squared would be? Okay, so what would u be? And of course, a is still going to be 1. So what would du be? What's the derivative of cosine x? Look, let's go ahead and try it. We have the dx and we have the sine x with du. So all of this right here goes to du. Do you agree? With the sign of the negative outside first. So that's going to turn into 1 over the square root of a squared plus u squared du. And we did it. All right, so what is the antiderivative of that mess? Sine, hyperbolic sine inverse of u, which we said was what? Cosine x. Over a, which we said was 1, so that doesn't really matter. Plus c. So did you see how that worked? Kind of, sort of. All right, let's try another one. Which one do you want to try to get this one to look like? The third one. We'll try it. So we need to know what an a squared is. What is a squared? 16. So a is going to be 4. What is u squared? So what is u? So what is du? But we don't need 3. We need 1. So there's a problem. What is it? In this problem, we have u squared minus a squared. But on our formulas page, what does it need to be? A squared minus u squared. And I showed you in the beginning how to fix that. What did I say? Bring the negative out front. So we have negative 1/3 times our integral of 1, and now we can flip it. A squared minus u squared du. Alright, so we have negative 1/3 times, what is the antiderivative of that? 1 over a. A we said was 4. Hyperbolic tangent inverse. U we said was 3x. A again we said was 4 plus c. So we're going to have that, what, negative 1/12? Questions? Because what we have is 1 over u squared minus a squared, and compare that to the third formula. It's the integral of 1 over a squared minus u squared. So to flip it around, we have to use that negative. Anything else? Mm-hmm.
Yeah.
Okay. I do not want to start chapter 9 tonight because chapter 9, let me pause this.